All right, everyone, welcome to the last screencast for Chapter 5. This one won't be quite as long as the others, but we're going to talk about something. We're just giving something a name, basically, model specification. We've already talked a lot about model specification. Basically, the idea of which variables do I put in and which variables do I leave out? How do I decide on the particular regression model that I'm going to run? So one of the issues is that we've seen the effects of omitted variable bias, right? Omitted variable bias causes the beta hat hypothetical distribution to be moved off of the true beta 1, right? And we've also seen about the problems of including irrelevant variables, right? If I include too many variables, then the hypothetical distribution is going to get really wide, all right? So there's a trade-off there, right? If I keep including variables in order not to have omitted variable bias, I could cause myself to fall into multicollinearity and not be able to reject the null. So you need kind of a three little bears approach to getting the model just right. Model specification is the process of doing that, of deciding which variables should be in the model and which shouldn't be in your model. Model fishing is the act of researchers adding or subtracting variables until they get a model that supports the claim they want to make. This is sometimes called p-hacking. And this used to fool people, but you're not really going to want to do this because you're not going to pull a fast one. Anyone who's had basic training in linear regression, anyone who's going to be reviewing your work is going to know when you are p-hacking. So you should really only include control variables when you suspect that leaving out that variable would cause you to have endogeneity. In other words, you should only include a control variable if it's correlated with both x and y in a linear regression. And the issue is that different models can produce different conclusions. Excluding a variable may cause omitted variable bias. Including a variable may increase multicollinearity and lead to high variance of the beta 1 hat distribution. Include a variable with missing data can require lowering the sample size, right? So if you have to throw out a lot of rows, then you're decreasing n, and by decreasing n, you're increasing the width of the hypothetical distribution, making it harder to reject the null hypothesis. Including post-treatment variables, these are variables that actually depend upon the independent variable of interest, can hide effects of a treatment variable. So the easiest way to think about this is things that are just really highly correlated. But they're correlated because there is a causal relationship between the independent variable of interest and the control variable. One is causing the other, all right? Certain good practices are going to help you reduce problems with model specification. And first of all, you follow that replication standard. All the stuff we said back in Chapter 2, people should be able to replicate your statistics. Use multiple specifications. Do multiple versions of the model. Pick one as your real model and put the others in an appendix. Or if it's a technical report, put them in an appendix for the technical report. Or if it's for a boss or something like that, in a consulting situation, keep them on the side, because if the client asks you, hey, wait a minute, I don't like the way you measured this, or I don't like the way you controlled for this variable. Did you try it this other way? If you can pull that out of your file and say, I did, and here is how it's different, or I did, and it's not different at all, it gives people a lot of confidence that you've thought through all the possible ways in which you might be wrong. So do those sorts of robustness checks. So these good practices, I already said that, and that's it. Wow, I should have I should have put that just as a tag on the end of the last one. But there you go. I said it would be short. I didn't realize it was quite that short, but that's it on model specification. You only want to include controls that you believe are correlated with both x and y. That's sort of the bottom line here. Sometimes when people run regressions on survey data, they'll often want to throw in other control variables like gender or age. Only include those controls if gender or age or race or whatever it is that you are tempted to throw in, if it's correlated with both x and y. Now, if you're interested in the effect of, say, age on your dependent variable, run a separate regression. Ask yourself the endogeneity questions and put in the proper controls to isolate the effect of age on your dependent variable. But don't try to use one model to understand the partial effect of a bunch of independent variables. It won't work. You'll have problems. You'll either be biased or you'll be multicollinear. So from the beginning, I've encouraged you guys to pick one independent variable of interest. How does that affect the dependent variable? Every other decision you make in terms of what control variables you want to include should be based upon those original two variables. And if you're interested in one of the other variables as an independent variable of interest, run a second model, ask yourself the question. Hopefully you already have the controls you need in the data set. All right, that's it. And that's the end of chapter 5.